Today we're going to talk about power and the difference between kVA and kW as it relates to the UPS industry. There are many different types of power, and sometimes it's easier if we break it down into just three: real power, reactive power, and apparent power. Real power is the energy consumed by a piece of equipment. An example of real power would be a filament in a light bulb or coils in a toaster. Purely resistive. Real power is depicted as kW. Our second form of power is reactive. Now, reactive is a type of power that's internal to a piece of equipment or consumed by a piece of equipment. It can be an example of a reactive power would be a transformer, maybe a fluorescent light bulb, or an AC motor. Reactive power is depicted as kVAR, kVAR. Our third is apparent power. Apparent power is a mathematical calculation of real power divided by reactive power, and we get kVA, or apparent power. Now let's show you the relationship between the three different types of power in a graph. And first we're going to show kVA. Then we have kW, and we have kVAR. The kVA is the input of the UPS. The kW is the actual real power of the UPS. And the kVAR is the energy consumed by the UPS, or in a UPS spec, the power factor. The lower our power factor is, closer to 1, the more efficient our UPS is, which lowers our energy costs and ultimately lowers our monthly energy bill. So Stephen, how does beer relate to the three different types of power?
Well, that's a good question. So that was the technical answer, and let me take a different approach. So in this demonstration, the entire mug, the foam and the beer, is depicted as kVA, or apparent power. The foam represents kVAR, or reactive wasted power. The beer, the actual consumable portion, represents kW, or the real usable power. So, in summary, if you keep your beer at the proper temperature and pour it correctly, you'll have more beer and less foam, or more real usable power, kW, and less wasted energy, kVAR, or kVAR. So, cheers to efficiency.